Hello everyone, my name is Chris Edwards and today we're going to write a SQL query. Our problem today involves a common fixture of toy SQL problems, a company org chart. A small-town tech support company is performing an HR audit of sorts. The CEO, Mira, wants to determine how many other employees each employee is responsible for. Every employee is responsible for themselves, as well as for all of their direct and indirect reports. For example, using the org chart above here, Angela is responsible for just one person, herself, while Laura is responsible for three people, herself, James, and Eddie. Mira, as the CEO, is responsible for everyone in the company. The company maintains the following two tables, employees and employee managers. We need to write a SQL query using these tables that returns the name of each employee along with the number of employees that they are responsible for. You can see our expected output here below. And with that, that's all the setup for today. If you want to have a crack at solving this problem yourself, there are links in the video description to this full problem statement and instructions on how to replicate this coding environment on your local machine. Feel free to pause the video now and come back later for a solution walkthrough coming right up. All right, welcome back everyone. We will now take a look at a possible solution to this problem. What we have here is a classic org chart problem requiring us to traverse the tree structure of the org chart in order to produce some kind of per employee summary. These kinds of problems are generally designed to demonstrate one very specific type of query, and this problem is no exception. If you've seen this kind of thing before, you're probably way ahead of me, but for those who haven't, I want to take a second to explore how you might figure out what you need to do by analyzing the problem. Okay, so to solve this problem at a basic level, we need to somehow associate each employee with all of their direct and indirect reports. In other words, all the people below them in the org chart. The first thing you might think to try is joining the employees table to the employee managers table to get a list of each employee's direct reports. Let's try that now. I have a query prepared here. So, as we would expect from the org chart on the left here, we can see Mira has 3 direct reports. Angela, Laura, and Maria. Laura has 2 direct reports, James and Eddie, and everyone else has no direct reports. This is a good start. Already, with this query, we could pretty easily return the number of direct reports that each person has, but a full solution to this problem also needs the indirect reports. In other words, the direct reports of the direct reports, and the direct reports of them, and so on. For each employee, we need everyone below them in the org chart, not just the first layer below them. So how can we get that? Well, you might try adding more joins, joining from the employee managers table to itself a few more times to get successively lower layers of the org chart. And that strategy would technically work if you could know for sure in advance how many layers the org chart has, and that the org chart was never expected to change in the future. But there is a much better way to go about it that will flexibly adapt to practically any org chart size and shape. We have a situation here where we need to join a dataset back to itself some unknown number of times until the chain of joins runs out of fuel, so to speak. In other words, runs out of employees to join to. This is a perfect example, some may even say the canonical example, of when you should use a recursive SQL query. I've discussed how recursive queries work in some detail in my earlier Fibonacci episode, but for a quick refresher, a recursive query needs 2 things, a base case and a recurrence relation. The base case is a static dataset that is used to get the recursion going. And the recurrence relation defines how to recursively construct the rest of the output from there. So what is our base case? If we look back at the problem statement, we can see this key statement here. Every employee is responsible for themselves as well as for all of their direct and indirect reports. The simplest part of this definition, the part that doesn't rely on any kind of joining or recursive logic, is this first part. Every employee is responsible for themselves. That sounds like a pretty good base case to me, so let's get that down here. Okay, next we need the recurrence relation. This can often be tricky to figure out, but I find it helps to try to state what you want in as plain and non-technical of language as possible, and that can often point you in the right direction. For each employee, we want to start with the employee themselves, then get all of their direct reports, then get all of those people's direct reports, and so on. This is describing a flow from managers to their direct reports. So we probably want a solution that goes from the top down, using the employee managers table to get from managers to their employees recursively. And this query should do it. In the first run of this recursion, the responsible for employee IDs are just the IDs of the employees themselves. That's from the base case here. When the recurrence relation half of this query executes, these IDs are treated as manager IDs and joined to the employee managers table to find those employees' direct reports, if they have any. The direct reports IDs then become the responsible for employee IDs, fueling the next run of the recursion. Those IDs are then treated as manager IDs, joined to the employee managers table to find their direct reports, and so on. And because we're doing an inner join here, the recurrence query only returns records when there are indeed direct reports to be found, and therefore the whole recursion ends once we have exhausted the entire org chart and there are no more employee to manager relationships yet to be traversed. So that's how this query works in a nutshell. We're not quite done with the solution, but we are really close. Right now, we have employee names and the IDs of all the employees that they are responsible for, and we just need to turn that enumeration into a count. We can use a group by statement to perform an aggregation at the employee name grain, get the count of IDs associated with each employee, and we should be good to go. I have that query prepared here. Let's run it. And sure enough, we get our expected output here, and we are done. Just a couple final thoughts before I leave you. One of the reasons that an org chart is such a useful device for exploring recursive queries is the fact that it is usually a tree structure. And in graph theory, a tree can be defined as a connected acyclic graph. The important part of that definition for our purposes today is the acyclic part. This means the graph has no cycles. In other words, there are no loops that allow you to travel from a node back to itself without any backtracking. Using the org chart example, a cycle or loop would look something like the CEO somehow reporting to the mailroom intern, or someone being their own direct report, or some other such nonsensical situation. It is actually the fact that org charts have no cycles that make them great fodder for recursive SQL queries. If, for example, the CEO did report to the mailroom intern, your recursive query would start at the CEO, go down the org chart all the way until it reaches the mailroom staff, then suddenly find itself back at the CEO again, with no choice but to go all the way around again, and again, and again, forever and ever. You would have an infinite loop, and your query wouldn't work. While there usually are some ways to protect against getting stuck in infinite loops, it requires some extra care and it complicates the logic a bit. So when you just want to demonstrate the core functionality of recursive SQL queries, it is a lot easier to just start with a scenario that will never have loops in it. And an org chart usually fits that bill. One last caveat about recursive queries. Earlier I claimed that they would, quote, flexibly adapt to practically any org chart size and shape. That is true up to a point, but there are practical system limitations. Many database systems have the concept of a maximum recursion depth, and if your recursive query recurses too many times, even if it isn't technically an infinite loop, the database will just error out to be safe. Sometimes you can tweak this limit in the system settings, but regardless, there usually is some limit beyond which recursive queries become impractical or impossible, and you should keep that in mind when writing a recursive query that could potentially perform an enormous number of recursive calls. As always, results will vary depending on the exact database you are using, your hardware limitations, etc. And that's it for this video. Thank you all for watching. If you have any further questions about this problem, or if you think of a different approach to the solution that I may not have considered, please let me know in the comments, and be sure to subscribe for more SQL query writing content in the future. Until next time, happy querying.